Good morning, students. Welcome to today's class. Children, for your information, in the last class I taught you about pressure in fluids and I gave you a formula for it, that was H rho G. I told you that the pressure was directly proportional to the depth of the point below the free surface of the liquid, and it was also directly proportional to the density of the liquid. So in today's class we are going to focus on laws of liquid pressure. Now let us look at the laws one by one. The first law of liquid pressure is that inside a liquid column, the pressure increases with depth. Now let us look at a few examples which I have picked up from our day-to-day life. When you, in case of a dam, when you see a dam, it is always narrow at the top, and as you go down, the wall of the dam becomes broader. The reason behind this is that as we move down, the depth increases and therefore the pressure exerted by the water on the dam also increases. Therefore, to withstand that tremendous pressure, the dam is broader towards the base. Now let us look at the second example. Whenever you see the water supply tank which is placed on a building or a house is always on the top. The reason being is that as we know that the pressure increases with depth, so what happens, it is easier for the water to flow from the higher level to the lower level, and also the force of gravity helps in the movement of the water. Now let us look at the third example from our day-to-day life. That is, you must have seen that when it is easier to swim in sea water than in river water. The reason behind this is that the density of the sea water is greater than the density of river water. Now why is the density of sea water greater? Because it has dissolved salts in it. So because the density of sea water is greater, therefore the pressure which is exerted by the sea water is more than the pressure exerted by the river water. Now look at the next example. When a diver has to dive inside a water body, he or she will wear special protective suits which are made from the glass, reinforced plastic or special cast aluminium. The reason behind this is the same. That is, when the diver has to go deep inside the water, as the depth increases, the pressure of the water on the diver's body also increases. If the diver has to protect his body, he needs to wear special protective suits. Otherwise, due to the tremendous pressure, the body will get smashed. Now we move to the next example. Here I have drawn a water tank and I have shown you a bubble rising from the bottom of the tank moving upwards. You will see that when the bubble is at the bottom of the tank, the size of the bubble is small. But as the bubble rises up, the size goes on increasing. The reason behind this increase in size is that below the bubble is experiencing a tremendous pressure due to the depth. Now as the bubble rises up, the depth reduces and thereby the pressure of the liquid on the bubble also reduces, and therefore it increases in size. So we looked at different examples which prove the same thing, that the pressure increases with depth. Now we look at the second law of liquid pressure. Or we can say the second law. Yes, the second law states that in a stationary liquid is a liquid which does not flow. The pressure is same at all the points on a horizontal plane. You can see I've taken, I've taken a tank of water and I have shown 3 points A, B and C. They are at the same depth. Now the pressure exerted by the liquid on all the 3 points is going to be the same because they lie in the same horizontal plane. The third law of liquid pressure is that pressure is same in all directions about a point in a liquid. I have drawn a point O in a liquid, and the pressure exerted by the liquid in different directions from this point is same in all the directions. That is the third law. Now we move on to the fourth law. Pressure at same depth in different liquids is different. I have taken 2 different liquids here. One is water and other is glycerine, and I have taken the position to be the same in both. They are at these 2 points are at the same depth in both the liquids, but the pressure exerted on them will be different because where is it going to be more? It is going to be more in glycerine because the density of the liquid is more. Density of glycerine is more than water. So therefore the pressure exerted at this point is going to be more. Now let us look at the fifth law of liquid pressure, and the fifth law of liquid pressure is, you can see that here I have taken different shaped vessels and they are connected by a common pipe. Okay, now when I pour a liquid from here, say water, the water will travel because they all are interconnected. The water is going to move from first to the second to the third to the fourth vessel, and ultimately I keep on pouring water, and after some time I will see that the water level in all the vessels will be at the same point. So this means that the liquid seeks its own level. That is, the liquid in all the vessels, irrespective of their shapes, are at the same level. So I have discussed 5 different laws of liquid pressure. Now I move to a very special law which was given by a scientist named Pascal, and it is known as the Pascal's Law, which is applicable in our day-to-day lives. For this I will also give you a small demonstration. Now first of all, let us see what does this law state. It states that the pressure exerted anywhere in a confined liquid, the meaning of the word confined is enclosed liquid, is transmitted equally and undiminished in all the directions throughout the liquid. You will understand this if you when you will see a demonstration which I am going to show it to you very soon. Yes, children, here I am demonstrating the Pascal's law to you. You can see that I have taken a confined liquid in a plastic bag and I have sealed the mouth of this plastic bag, and this is a confined liquid. According to the statement of the Pascal's law, when we apply pressure at one point on a confined liquid, that pressure gets transmitted equally and undiminished in all the directions. So what I have done, I have pierced tiny holes in this plastic bag and I have filled it with water. Now you see, when I apply pressure at the top point here and press it, you can see that the water is oozing out from the different holes which I have pierced in this plastic bag. So this proves that when I am applying a pressure at a point, it is getting transmitted equally and undiminished in all the directions. Okay students, now after the demonstration of the Pascal's law, we move on to its applicability. Where is it applied in our day-to-day lives? It is applied on different hydraulic machines like hydraulic jack, hydraulic press and hydraulic brake. In order to have a better understanding of these hydraulic machines, we will study the principle of a hydraulic machine. Now let us look at what does the principle of a hydraulic machine state. It states that a smaller force applied on a smaller piston is transmitted to produce a large force on a bigger piston. Now let us see how. Here I have drawn a hydraulic machine and you can see there are 2 cylinders, one smaller and the other larger. The smaller has an area of cross section A1 and the larger cylinder has an area of cross section A2, and both are fitted with frictionless pistons. What am I doing over here is that a force F1 is applied in the downward direction on the smaller cylinder, and you can see they are interconnected by this connecting tube and it is filled with water. Now when a force F1 is applied on a smaller cylinder in the downward direction, according to the Pascal's law, it gets transmitted to the other cylinder having a larger area of cross section, thus producing a greater force F2 in the upward direction. Now according to the formula for pressure, we have studied pressure is thrust upon area. So the pressure P1 in the smaller cylinder is equal to F1 upon A1, and the pressure P2 on the larger cylinder in the upward direction will be equal to F2 upon A2. According to the Pascal's law, both the pressures are going to be equal because this pressure is going to get transmitted in the second cylinder, is going to get transmitted to the second cylinder. So therefore I write P1 is equal to P2. Now what does P1, what is the value of P1 over here? F1 upon A1, and is equal to what is P2? F2 upon A2. When I cross multiply, I get F1 A2 is equal to F2 A1, and from here I deduce the principle, that is F2 upon F1 is equal to A2 upon A1, and this is known as the principle of a hydraulic machine. It will be used to solve the numerical problems. Now here one more important thing is that the area of cross section A2 is greater than A1, I have already told you, and the force F2 is also greater than F1. Therefore, a hydraulic machine is a force multiplier. Why is it a force multiplier? Because we are applying a smaller force, and that is that produces a larger force in the larger cylinder. So therefore it actually multiplies the force which is being applied by us. Therefore all hydraulic machines are called as force multipliers. Okay, now we move on to the explanation of the first type of hydraulic machine, and that is known as a hydraulic press. In your textbook you have a proper diagram of the hydraulic press, and it is quite complicated, but you're not supposed to learn that diagram. You can only visualize it, but I will just explain you the different parts of a hydraulic press. I have prepared shorthand notes here. Now in a hydraulic press there are two types of tanks. One is a smaller tank, which is also called the smaller cylinder. The name given to it is pump plunger, and the larger cylinder is called the press plunger. Okay, now a force F1, which is let us suppose force F1 is applied on the smaller cylinder, that is the pump plunger. When that force exerts a force on the bigger cylinder, that is, it exerts a force on the press plunger. And when this force, that is F1, is being produces a force F2, it actually gets the plunger move upwards, and there is a fixed roof there on the top on which you place cotton bales or sugarcane or oil seeds, and when that gets pressed against the fixed roof, we are able to extract juices and different oils from it. Now therefore we say that a hydraulic press, let us look at the uses. A hydraulic press is used to press cotton bales. It is used to extract juice from sugarcane. It is used to squeeze out oil from oil seeds, and it can also be used to engrave monograms on goods. So this is the use of a hydraulic press. Now we look at the second hydraulic machine, and that is a hydraulic jack. Here I have drawn a simple diagram for you of a hydraulic jack, showing a hydraulic jack. You can see there are two tanks over here. One is a smaller one and the other is a bigger one. There is a handle fixed on the smaller tank. When a force F1 is applied in the downward direction, the force is exerted in the downward direction, which actually causes the liquid to flow to the other vessel, and that exerts a force on this valve. The valve opens and the liquid rushes up here, producing a force F2 in the upward direction. Now what is a hydraulic jack? It is used to lift heavy vehicles in service stations for repair, etc. Now a car is parked on the bigger cylinder. When we apply a force on the smaller cylinder in the downward direction, that causes the force to multiply and raise this platform on which the car is parked, causing the car to be lifted up. And thus when the car is lifted up, this valve closes and we are able to repair the car or have a car wash. And as soon as the work is over, the liquid returns back to the first cylinder as the valve opens, and thus a hydraulic jack is useful for this purpose. Now we go to the third and the last type of hydraulic machine, which is called a hydraulic brake. Now in case of a hydraulic brake, again there are two cylinders. One is a smaller cylinder, another is a larger cylinder. This hydraulic brake is basically used in vehicles like cars to slow down or stop the vehicle. And in hydraulic brake there are two cylinders. The smaller one is called the master cylinder and the larger cylinder is called a wheel cylinder. Now I have drawn a small sequence for you over here, that how does this work. Actually what happens, we have a foot pedal inside the car which is used as the brake. Now when we press that brake when pressed gets applied as a force on the master cylinder, which is inside the bonnet of the car, in which brake oil is filled. So when we press the brake foot pedal, the force F1 is applied on the master cylinder, which lets the brake oil to rush towards the wheel cylinder. Now when the brake oil moves to the wheel cylinder, it applies a force F2, and that force F2 is transmitted to the brake shoes, which actually press against the wheel and open up. Okay, now when the brake shoes press and open up, what happens is that they touch the rim of the wheel of the wheel of the car, and then the brakes are applied. So this is the sequence in which hydraulic brake works. That is, we press the brake, causing F1 to be exerted on the master cylinder, leading to the brake oil to be moved out, causing a force F2 to be exerted on the wheel cylinder, which is present near the wheel of the car, leading to the opening up of the brake shoe, and finally the brakes are applied. So this way we had looked at three different types of hydraulic machines, that is hydraulic press, hydraulic jack and hydraulic brake.